So I wanted to start with introducing the concept of what's called a transducer. And what a transducer is it's something that converts one form of energy into another form of energy. And in this case, we're specifically talking about what are called electroacoustic transducers. They convert electrical energy into acoustic energy or the other way around. So we've got three examples here. We have guitar pickups, we have a microphone, and we have a speaker. And they all essentially function the same way. They are a copper coil wound around a magnet. The pickup is the simplest and most crude version of that. Basically, when you pluck a string, it excites the magnetic field, and that creates a really tiny little electrical signal. It comes out of the output jack, goes into the guitar amp, and then gets amplified from there. The microphone is a little more sophisticated, but it is the same essential principle. I'm not going to try and open it. So still a copper coil wound around a magnet. You speak into the microphone, it vibrates the microphone, and it creates a small electrical current. Speaker does the opposite. You feed it an electrical signal, it causes the magnet to vibrate and creates sound waves. Technically speaking, you could wire this in such a way where you could speak into it and have the sound come out of the microphone, because they are the same thing, just this is physically larger because the sound comes out of it. The Yamaha Subkick microphone was basically done doing that. They used a speaker and wired it in reverse so that it would act as a microphone. And so that's a transducer. Now, the electrical signal generated by a microphone is not nearly powerful enough to drive a speaker, and so we need to amplify it. We have our amplification. So we actually go through 2 rounds of amplification. We start with our microphone signal, someone's speaking or singing into the microphone, or we have the microphones on a guitar amplifier or something like that. We go to our microphone preamplifier. This will amplify our signal from microphone level to line level. So we'll start with the preamplifier to amplify the microphone level signal to line level. And we go from line level to speaker level using a power amplifier. This will be our second amplification stage. And once it's been amplified by that second stage, we get our speaker level signal, which will actually drive the speaker. And once you've done that, you can speak into the microphone and the sound will come out of the speaker. And there's our signal levels. Next thing I'll go over is signal processing. So first, we have an equalizer. Equalizer we use to change the frequency response. Generally speaking, because microphones aren't perfect, they don't give you a perfectly flat response when you speak into them. There's a bit of a curve to it. We want to equalize that to make it sound more natural, to make it sound more like the person's voice. And that's what equalization helps us do. For instance, there is what's called proximity effect. And when your mouth is right up against a cardioid microphone, which refers to the pattern that it picks up sound with, there's a big buildup of low frequencies. And that's one of the things we want to use the EQ to carve out of the signal. In addition to that, humans are inconsistent in their volume, and so we have compressors. A compressor will allow us to even out the volume level of a sound source. And then in addition to that, for more fun and flavor, we have reverb and delay and other various wet effects that we can apply to the sound. And these would go in between the preamplifier and the power amplifier. Last in the chain, directly before the power amplifier, we have another form of equalization for the speaker, because just like the microphone, the speaker is not perfectly flat. It does not give us a perfect representation of the sound going into it. And so we can use the equalizer to give us something closer to a perfect neutral response. And finally, we have a crossover, because within this speaker here, there are actually 2 speakers. This is a speaker cabinet, and then inside the cabinet we have a woofer and a tweeter. The tweeter is for reproducing high frequencies, and the woofer is for reproducing low frequencies. But the speaker isn't smart enough to just do that on its own. You have to tell it what to do. So we use this crossover here to use a filter that will give the speaker low frequency information to the woofer, and it'll send the high frequency information to the tweeter. So next is figuring out how to wire all this up. So we want to run into a variety of different connectors and cables in audio, which is how we connect everything together. We have XLR cable. XLR doesn't exactly stand for anything. It started with a company called Canon. They had their X connector, and that's where the X comes from. The L is for the latching mechanism on the female end. And then, if I remember correctly, the R refers to a rubber insulation added to the cable. I believe most XLR cables are technically only XL cables and are lacking that R component. Either way, we call them XLR. Now, people who are really pedantic will say there's no such thing as an XLR cable, and they will say that it is an audio cable with XLR connectors on it. I think that's needlessly pedantic, but I feel it important to mention. This is a mono cable, meaning it is only capable of carrying one channel of audio. So, for example, a microphone. It's also possible to send a stereo or two-channel signal down one wire, run one cable, and using two wires on that cable. And we'll get into that when I talk about TRS. Next, we have our quarter-inch phone connectors, and they're called phone connectors because they were actually used on phones. If you've ever seen footage of switchboards, that's what these were for. And then they were reused for mainly for guitars, but also for keyboards and other instruments. These are often just called instrument cables. They are mono, much like our XLR cable, and these are technically what's called unbalanced. I'll get into balanced versus unbalanced in a minute, whereas these are considered balanced. Another balanced cable, well, a cable that is capable of being balanced, is our TRS cable. So the biggest difference here is on the TS, or tip sleeve cable, we have a single ring around right below the tip of the connector. On a TRS cable, there we go, we have two rings. And so we can wire we have multiple conductors in this cable that allow it to carry either a balanced mono signal or an unbalanced stereo signal. So essentially, with balanced and unbalanced connections, we have two signals being sent down the same wire, and one of them is polarity reversed with the other. And basically, when you have noise coming in from outside, that is always going to be one polarity. But the two signals on here are opposite polarities. And so when they get combined at the input stage, any sound that is the same on both wires gets canceled out. So they're effectively noise canceling. We don't get that benefit on our unbalanced cables. There's a lot of caveats there for anybody who's being overly pedantic, but that's kind of the basics. So with a TRS cable, we can actually do either a mono-balanced signal, like with the XLR, or we can do stereo unbalanced. So we can use those two conductors on the cable to send two different channels of audio. This is how headphones work. Headphone cables use a TRS connector, and they send the left and right channels down the two wires inside the cable. Now, whenever you're looking at a piece of gear, it'll have various connectors on the end that give you a clue as to how to wire it up. Right here, it's labeled inputs and outputs, and we have XLR connectors and quarter-inch connectors. You can use either one in this case. They're wired in parallel. So typically, XLR connections are preferred because we got this nice locking connector here. It's balanced. It's going to be a lower noise connection than if we use quarter-inch in many cases, like so. Like with our preamp, this EQ here has inputs and outputs, and you'll even notice it'll say balanced and unbalanced. So because these quarter-inch connections are unbalanced, if you use them to connect this to your equipment, the whole connection will be unbalanced. If any part of a chain is unbalanced, then the entire chain is unbalanced. We have another example here. We have both XLR. We have both XLR and quarter-inch, and this is on our compressor here. So that will determine what type of cable you use. Talking about headphones earlier, we have an 1/8" version of our TRS connector. It's the same the connector works in the same way, it's just physically smaller. You can have an XLR connector on the other end of the cable. This is great if you need to connect a piece of equipment that has only XLR to a piece of equipment that only has quarter-inch or 1/8". Also, so people will buy a cable like this and expect to be able to, say, plug in their smartphone, if they have one that still has a headphone jack, and connect it to a mixer, and then they'll wonder why it sounds bad, and it's because this is mono only, because it's got XLR. I think it's technically possible to wire XLR in stereo, but you're never going to find a piece of equipment that has a stereo XLR input. So as a result, you're sending 2 channels of audio, and then they are getting canceled out on the other end. And so you just are left with this strange hollow sound. So anytime you want to send stereo, you need 2 cables. You may have a stereo output, like your headphone jack for your phone, but if you're connecting it to something like a mixer isn't going to have stereo inputs hardly ever, and so as a result, you split it into 2 mono channels. I meant to mention this earlier, so I'm going to just mention it now. We talked about how to get the microphone into a speaker, but how do we get a guitar into that? We go from our output jack and connect to the input jack of a guitar amp. A guitar amp functions exactly the same way. We have a preamp that amplifies the signal to line level, and we have a power amp that amplifies it to speaker level, and then a speaker. And we have it all in one convenient combo. With guitar amps, you'll sometimes have them in combo format, and sometimes you'll have a separate head and speaker cabinet. It's all really the same thing, it's just whether it's located together or not. In addition to that, loudspeakers can also have a power amplifier in the back. You'll notice that this one simply has 2 speak-on connections because it has no amplifier in it. It's just a couple of speakers wired together inside a wooden cabinet or plastic, as the case may be. And then with speakers like our house mains here at the church, we have amplifiers built into the speakers, and so you can just connect your XLR cable, sending a line level signal to them, and then the amplifier that's inside the speaker will amplify it to speaker level. Next, we get into mixers, because it's nice when you have this big stack of gear, but it only works with 1 channel, unless you have a mixer. A mixer allows us to mix several signals together and send them to a single pair of outputs. Now I'm going to turn this around for the benefit of those who are physically here. You'll see we have a number of inputs and outputs on the back of the mixer. I'll even see if I can get this on camera for a second. So we have all of our XLR microphone inputs. We have high Z inputs. Many mixers do not have high Z inputs, but that is for our electric guitars, acoustic guitars. Allows you to connect directly to the mixer without what's called a DI box. Speaking of which, now is a great time to mention DI boxes. I talked about balanced and unbalanced signals earlier, so we've got the high Z inputs on this mixer, so you can connect a guitar directly to it. Since many mixers don't have that, we also have what's called a direct inject or DI box. This one is a Radial J48. It is an active DI box, so you can use phantom power to power the preamp that is inside it. But basically, we're connecting our guitar to the input, and then we're going XLR out of the output. This converts it from unbalanced instrument level to balanced microphone level. Now on this mixer, we have several channels. In this case, we have, I believe, 16 channels. And so the signal flows from the input on the back and down each channel strip. These then connect to a bus bar that runs the width of the console. And we have a number of different buses. We have our main or master bus here, and that's for our main mix. It's meant to feed our speakers. We also have 4 what are called aux buses. Aux meaning extra, supplementary. Aux is short for auxiliary. And so those are our auxiliary buses. And those are often used for things like monitor mixes. They can be used for effects. And we also have subgroups. Subgroups allow us to send a group of channels to a pair of faders here, and we can apply processing to that group. So the audio signal from the channels will flow through the bus bar, reaching the subgroup. We can apply signaling to that signal. We can apply processing to that signal, and then after that, it will hit the mains. So if we go through this one at a time, we have our phantom power. That is for things like condenser microphones. They require an additional amount of current. It's represented by this plus 48 volt button here. We have our sensitivity or gain control. Gain is the means by which we amplify the microphone level signal to line level. We plug our microphone in, we turn our gain up. There's a op-amp preamplifier inside here, and that we're applying gain to the microphone level signal, bringing it up to line level. We have a button labeled range here. This is a pad. If we have an extremely loud signal coming in, it might be too much. It might be so loud that even with the gain all the way down, that it's still greater than line level. We can use a pad to knock off some of that volume level and give us a bit of wiggle room here. We also have a polarity flip. So that's essentially, if you've ever seen a sine wave, goes like this, polarity will just invert that wave. We have a high pass filter, also sometimes called a low cut, because it cuts low end, but what it's literally doing is allowing high frequencies to pass through it. This one is fixed. I believe it's set to 70 or 80 hertz. On some mixers, you have the ability to adjust what frequency that high-pass filter engages at. It cuts low frequencies at a slope, and the lower in frequency you go, the more they get cut. So with a high-pass filter set to 80 hertz will be cut a small amount, and then 100 hertz will be cut more, or sorry, not 100 hertz, 60 hertz will be cut more, 40 hertz will be cut more, and so on until you get lower and lower in frequency. Then we have our equalization. Every single channel gets a full 3-band equalizer here. No, this is 4-band. On a lot of mixers, it may only be 2 or 3 bands. So that is essentially like having one of these on every single channel. And we can use that to adjust the frequency response. We have our auxiliaries. So again, those are buses that are running the width of the console, and we're actually sending the electrical signal that is coming down the channel strip into these auxes, and then they're coming out these outputs here. So these are the master level controls for those, and these are individual controls for sending those channels to those auxes. We have a pan control, which if we rotate it to the right, it will send more of the channel signal to the right channel of the mains and less into the left channel. If we leave it in the center, it'll be equal in both channels. And finally, if we turn it to the left, it'll be more in the left channel. Then we have a number of switches here. So with this Soundcraft mixer and a lot of Yamaha mixers, it will have an on switch. If it's on, it means it's live. The signal is going to the main bus. If we don't have it engaged, the signal will not pass through. It will not reach the bus. On many other mixers, you'll see a mute switch instead, which just has the opposite function. If it's engaged, it will not allow signal to pass through. We have a mix switch, which sends it to the main bus, so you don't have to send every channel on here to the main bus. In fact, you don't have to send any of them. But you do need that engaged if you want it to be in that mix. We have our 1, 2, and 3, 4, which are referring to our 2 subgroups here. We also have a mono master bus controlled by this control here. That's if we're using a mono system. And then we have PFL, which stands for pre-fade listen. That will go to our engineer's monitor. That will come out of this phone jack. I believe there's also an output on the back for that as well. We've got this mixer, and we can use it to do things like applying reverb and delay to one or more channels. We would connect the output of one of our auxes to the input of the reverb unit, and then we send the channel that we want to have reverb on it to the aux, and then the output of the reverb unit will come into a pair of channels on the mixer, if we want stereo at least. And then as you turn those up, that will send the reverb, and only it will send the vocals that are going through the reverb and the reverb out from the channels into the main bus. And that's called a send and return. You're sending the output of the auxes into the input of the reverb, and then the output of the reverb is coming through into the channels, and then those are going to the mains. Any questions so far?